Hello guys, once again on inverse trigonometry. Right now we are taking some good questions in which we will simplify like this question. Prove that tan inverse 1 over 3, tan inverse 1 over 5 plus tan inverse 1 over 7 plus tan inverse 1 over 8 equals to pi by 4. So we have to prove the sum of all these tan inverse is pi by 4. So we will manipulate this question we take these two tan inverse in a pair, and again we will take these two tan inverse in second pair, and we will use the sum of two tan inverse, just like tan inverse x plus tan inverse y equals to tan inverse x plus y over x minus y. So we use this formula. When we apply this formula on this pair, that is tan inverse 1 by 3 plus tan inverse 1 over 5. So according to this formula, first tan inverse 1 over 3 plus 1 over 5 divided by 1 minus product of these two values, and we get tan inverse on taking LCM, that is 15. So we get 5 plus 3, so 8 by 15, and in denominator when we take LCM 15, so it is 15 minus 1, we get 14 over 15. So we cancel out these and we get tan inverse 8 over 14, or you can say 4 over 7. And on the other side we have this pair tan inverse 1 over 7 plus tan inverse 1 over 8. So on using again the same formula, we have tan inverse 1 over 7 plus 1 over 8 divided by 1 minus product of these, and this product always less than 1. It's a restriction. So after taking LCM, this is tan inverse, LCM is 56, so we get 8 plus 7, that is 15, 15 over 56, and there is 56 minus 1, that is 55. So when we cancel this 56, we get tan inverse 15 over 55, or you can say it is 3 over 11, and this is 4 over 7. So this becomes tan inverse 4 by 7, and this becomes tan inverse 3 by 11. Right now again we have one more pair of tan inverse, and we can also use the same formula as we have applied this earlier. So it is tan inverse x plus tan inverse y. As a result, we get tan inverse 4 by 7 plus 3 by 11 divided by 1 minus the product. So on taking LCM, that is 77, we get 44 plus 21, that is 65 over 77. Again in denominator, LCM is 77, this is 77 minus 12, so we get 65 over 77. So we can cancel out these and we get tan inverse 1. And we know very well 10 pi by 4 is 1. So this is tan inverse of 10 pi by 4, and we are using the theorem tan inverse of tan theta. As a result we get theta. So these will be neutralized and we get the answer pi by 4. So it is the right hand side. So it is proved that the sum of all these tan inverse is pi by 4. Now the next question. So in this question we have twice of tan inverse half plus tan inverse 1 by 7. Right now this is the 2 tan inverse half. It is just like 2 tan inverse x, and the inverse trigonometry, twice tan inverse x is the formula, that is tan inverse 2x over 1 minus x square. So we use this right now. It is tan inverse of double of this divided by 1 minus x square. So it is just like x. So when we apply this, then we will twice of this over 1 minus half square, and tan inverse 1 by 7 as it is. So in this case, this will be cancelled out. We get 1, and 1 minus 1 by 4, it is 3 by 4. So on reciprocation, we get tan inverse 4 by 3 plus tan inverse 1 by 7. Right now we have the summation of two tan inverse. So we use the theorem tan inverse x plus tan inverse y. That is tan inverse sum of xy divided by 1 minus product. So it is 4 by 3 plus 1 by 7 divided by 1 minus the product of these. So on taking LCM, that is 21, we get 28 plus 3 is 31, 31 over 21, and there is in denominator, on taking LCM 21, we get 21 minus 4, that is 17 over 21. So when you cancel this, you get tan inverse 31 over 17. So this is the right hand side, hence proved. So from left hand side to right hand side, both are equal. So this is the answer, tan inverse 31 over 17. Now the next question, but this question is different from the last two. Last two questions were in terms of tan inverse. There was 4 tan inverse, and on summation we were taking the pairs, and the 2 tan inverse x and tan inverse x. So we operate the previous two questions in terms of tan, like we were using the formula 2 tan inverse x or tan inverse x plus tan inverse y. But right now we have hetero system. It is cos inverse and this is tan inverse, and as a result we want tan inverse. So we have two options. You take this tan inverse 3 by 5 on right hand side, so you will get the subtraction of 2 tan inverse, and you solve that using the formula tan inverse x minus tan inverse y, and finally you get the result tan in terms of tan inverse, and that you will convert that in cos inverse. Or you have one more option. First you convert this cos inverse in terms of tan inverse. So how will you do this? Let us consider cos inverse 4 by 5 as theta. It means cos theta is 4 over 5. That is base over hypotenuse. We draw a triangle in which base is 4 and hypotenuse is 5. So the requirement of perpendicular. So we use the formula perpendicular equals to this, and this is 5 square minus 4 square, you get 3. So it becomes 3. We want the value of cos inverse in terms of tan inverse. That's why we can use the formula of tan inverse, summation of 2 tan inverse. So the tan theta from this triangle will be perpendicular over base, that is 3 by 4. So tan theta is 3 by 4. It means theta is tan inverse 3 by 4. This becomes, when you take tan on right hand side, you get theta equals to tan inverse 3 by 4. And what is theta? Theta according to this is cos inverse 4 by 5. When you put this in place of theta, you get this. So it means cos inverse 4 by 5 is equivalent to tan inverse 3 by 4. Now we can use this value in place of cos inverse. So we put this tan inverse 3 by 4 at this position. It means right now on this position we will place tan inverse 3 by 4 plus we copy this tan inverse 3 by 5. Right now we have the sum of 2 tan inverse. So we can use the formula tan inverse x plus tan inverse y. It means tan inverse sum of these two divided by 1 minus the product of these, and this product should be lesser than 1. So right now this is 9 over 20, so it is correct. 3 by 4, 3 by 5, and that becomes 9 by 20, which is less than 1. So it is correct. We can use this formula. And on taking LCM, that is 20, so we get 27 over 20, and this is 20 minus 9, that is 11 by 20. On cancelling this, we get 27 over 11. So this is the required or desired result. We have this answer, means right hand side of the question. Now the next question, prove that sine inverse 8 by 17 plus sine inverse 3 by 5 equals to cos inverse 36 over 85. So the left hand side is in terms of sine inverse, and this result is in terms of cos inverse. So first we consider this sine inverse as theta. Sine inverse 8 by 17 equals to theta. It means sine theta equals to 8 by 17. So we draw a right angle triangle in which perpendicular is 8 and hypotenuse is 17. So we will collect the base, and on solving this, base equals to 17 square minus 8 square, we get 15. So it is 15. And we want the value of cos theta. So cos theta equals to b over h, that is 15 over 17. It means theta equals to cos inverse 15 over 17. And what is theta? Theta is sine inverse this. So it means sine inverse 8 by 17 is equivalent to cos inverse 15 over 17. Now we convert this in terms of cos inverse again. Right now we have sine inverse 3 by 5. We consider it as a angle phi. So sine phi equals to 3 by 5. This is perpendicular over hypotenuse 3 and 5. So we calculate for the base, that is 5 square minus 3 square. It means it is 4. And the value of cos phi will be base over hypotenuse, that is 4 over 5. So right now cos phi equals to cos inverse 4 by 5 and phi equals to sine inverse 3 by 5. It means sine inverse 3 by 5 is equivalent to cos inverse 4 by 5. This is a conversion of one trigonometric function into other. So this way sine inverse 3 by 5 is converted to cos inverse 4 over 5. Right now we have the value of sine inverse 8 by 15 as a cos inverse 15 over 17, and similarly sine inverse 3 by 5 is cos inverse 4 by 5. So we can substitute both values as cos inverse. So it is sine inverse 8 by 17 becomes cos inverse 15 by 17, and sine inverse 3 by 5 as a cos inverse 4 by 5. So we put these. Right now we will use the formula of 2 cos inverse. That formula is cos inverse x plus cos inverse y equals to cos inverse x into y. As it is, we will take these values, minus under root 1 minus x square into under root 1 minus y square. So this way it is just like x and this is just like y. So we use this formula, that is cos inverse x into y minus under root 1 minus x square under root 1 minus y square. So it is 60 over 85 minus, on solving this we get 64 over 289, and this is 9 over 25. So on taking under root we get 8 over 17, and this is 3 by 5. So it is 5 into 17, and the LCM is same 85, and the numerator is 60 minus 24. So we get 36 over 85. This is our desired result, or you can say this is the right hand side, hence proved. Now the next question, that is sine inverse 1 over root 17 plus cos inverse 9 over root 85 equals to tan inverse 1 by 2. So all inverse are different. So first we try to convert these inverses in the similar inverse trigonometric function. Like we have sine inverse this, so we convert it in tan inverse, and the same it is cos inverse this, we will convert it to tan inverse. Then we get the 2 tan inverse, we can apply the formula tan inverse x plus tan inverse y. So first we will convert these. So the conversion of one trigonometric function into other. So right now we consider it as a theta. It means sine inverse 1 over root 17 equals to theta. That means sine theta equals to 1 over under root 17. So it is perpendicular over root 17 as a hypotenuse. On solving we get the base 17 minus 1, that is 16. On taking root is 4. It means base is 4. So from this triangle we will collect the value of tan theta. So tan theta is perpendicular over base, so it is 1 over 4. So tan theta is 1 by 4. It means theta is tan inverse 1 by 4. And what was the theta? Theta was sine inverse this. It means this sine inverse 1 over root 17 is converted right now in tan inverse 1 by 4. So these are equivalent. Now we convert this cos inverse again in tan inverse. Now we consider cos inverse 9 over under root 85 as phi. It means cos phi equals to 9 over under root 85. And when we draw a triangle and angle is phi, so it is the value of cos phi, that is b over h. So it is 9 and it is root 85. Right now we collect the perpendicular. So the perpendicular is 85 minus 81. So we get under root 4, that is 2. It means its value is 2. Now on getting all these values of triangle, we can collect easily the value of tan phi. So tan phi equals to perpendicular over base, so it is 2 by 9. That means phi equals to tan inverse 2 by 9. And what was phi? Phi is cos inverse this. That means this cos inverse is now converted into tan inverse. So these are equivalent. Right now we substitute these sine inverse and cos inverse in terms of tan inverse, and we put these values on these positions. So as a sine inverse 1 over root 7 will be tan inverse 1 by 4, and in place of cos inverse this we will use tan inverse 2 by 9. So right now tan inverse 1 by 4 plus tan inverse 2 by 9. So the left hand side right now manipulated or converted into tan inverse. It was sine inverse and cos inverse. Right now it is converted into tan inverse. And this is the sum of two tan inverses. So we can use the formula of this. Tan inverse x plus tan inverse y equals to this. It means tan inverse equals to summation over 1 minus product, and the product 1 over 4 and 2 by 9 as xy should be lesser than 1. So right now we are getting the value 2 by 36, or you can say 1 over 18, that is lesser than 1. So it is true, we can use this formula. So tan inverse on taking LCM, it is 9 plus 8, that is 17 over 36, and on taking LCM of denominator we get 36 minus 2, that is 34 over 36. So on cancelling this we get tan inverse 17 over 34. So again this will be cancelled out. We get tan inverse 1 by 2 as a final answer. It is our required result. So this is the same. So it is right hand side, hence proved. So this way we can use the theorems as we have discussed earlier in previous classes. That is the conversion of one type of inverse into others, and we also studied the sine inverse x plus sine inverse y, cos inverse x plus cos inverse y, tan inverse x plus tan inverse y formulae, or you can say 2 tan inverse x also. So this is the scenario by using those theorems we can solve these inverse trigo. Thanks.